Hi, this is a quick walkthrough of how you can build an image classification model in TensorFlow and upload it to work in the browser in JavaScript so anyone can access it from their computer. So the model that I used or that I built was one that predicts whether a person is sitting up straight or slouching, and it uses your webcam to take snapshots of you sitting in front of the webcam, and it inputs it into an image classification model to determine whether you're slouching or sitting up straight, and then it outputs it back to you. I'll show you quickly what it looks like and then how I built it. So this is the model. I'm going to turn on the recording, so I'll stop my video. So here's me sitting up straight, and it says I'm sitting upright, and then I'm going to slouch, and it picked up on me slouching, and then I'm going to sit up straight again, and here it is, and again I'm slouching. So I'm going to stop this. So the way that it works, so the first part is getting the training images, then building a model, then putting it up online. But I'm going to start with describing the model itself. So the model, I borrowed heavily from this tutorial from Francois Cholet about how to build an image classification model with TensorFlow. And if you're interested, you could look at his notebook. But essentially, it builds this model here, sequential model, convolutional 2D model with dropout, which basically means it's dropping some units out so that the model doesn't kind of over rely on them and maybe makes it a little bit more robust. Here is the input pipeline, this part, and you could see that he also incorporated data augmentation. So over here, you can see that the images are rotated a little bit randomly, and they're transformed in other ways. They're translated up and down, zoomed in and out. And again, that's also to make kind of the model more robust, basically artificially adding training images. So you have a certain set of training images, and then they're transformed so that you basically can multiply the number of images that your model is trained on without actually having to get out and get more images. So that's data augmentation. That's in the input pipeline. And then this is where the models actually run down here. So I borrowed heavily from this code, and you can see my code looks just like it. I have data augmentation, but mine is a little bit, it doesn't rotate it as much, doesn't move it as much, because if somebody's sitting in front of their webcam, I assume that images are fairly standard. Probably it doesn't make sense to rotate them 40 degrees necessarily. So I did include a little data augmentation. I did include a dropout layer also, so that the model is maybe a little more robust, harder to overfit a little bit. And I also included transfer learning from MobileNet. And transfer learning basically takes a kind of pre-trained model. This one's trained on ImageNet, and then it just adds a couple, some layers on top of it. And that's to help, again, if you don't have so much training data, it makes sense to use, kind of pre-built model to get a lot of the basic things out of the way, things like lines and shapes, basic, maybe body parts or something. So the model can already kind of recognize those, and maybe there's less the model needs to train. So, if you don't have that many training images, like I did not, that could be very helpful. I found it was very helpful for my model. So that's very quickly the model. And converting a model to be put online involves a couple of steps. First, you have to put it through a converter for TFJS, TensorFlow JavaScript. And let me show you the steps for that. So if you go here, tensorflow.org/js/guide/conversion, it shows you the steps. And the first part is to save the model, model .h5, for example, is what you could call it. And use this this library to convert it into a JSON file and a bin file, and I'll show you what that looks like. So here I am in Colab, and let me upload the model. All right, just gonna upload it here. So it's loading the model. It's in Colab, and this is actually not the right one. This is the one I meant to use. So here, okay, so here it is already. So here's that file. So I did model.save, first of all. I saved it as H5 file after I built it. So there it is. And then I loaded it into here. I installed Tensorflow JS, and then I ran this single line of code where it's picking up that file, my model, and I'll show you what it does to it. It creates a bin file and a JSON file with information from the model so that you can then upload online. So here are those two files, a JSON file and the bin file. And what I would do then is download those files and upload them to the page that will be using them. So to make the predictions, it's, I think, 2 lines of code. So this code here for this Keras model, and then make a prediction, which is, let's see if I could find that code. Here it is, model.predict, and that's the main part of it. So to see an example in action, you can go to this tutorial here, github.com/tensorflow/tfjs-examples/tree/master/MobileNet. And you can see this example here. Oh, 1 second. Not that one. Here, see this example right here on the bottom. So that opens up this window. And this basically implements that code. So you can upload an image of a cat, and it can try to classify the cat. So I borrowed this code, and I made some changes. I made my own examples, different examples for it. So here's one, classifies flowers. Here's another one, classifies landmarks in New York City. And that's based on the same code. And this is what it looks like. So here you see that line that I showed you earlier, tf.loadLayersModel. So that's where it loads the model. And then my model.predict, and that's kind of the meat of it. And then the code has a lot more useful functions. So this was the basis for my project. So these I built in the past, but my model built on that. So what I wanted to do was have a video that was recording somebody sitting in front of their webcam. It would take snapshots and then basically upload those snapshots to this type of thing, so that it can categorize them as slouching or not slouching. And I think you saw that example here where it recorded me slouching and sitting up straight. And the hard part was getting training images. So to get training images, before building this thing, I built a page just to get the training images. And it's exactly like you saw before, but instead of making a prediction, it just saves the images. And the user can click slouch or not slouch, start the recording. And sorry, this is me slouching and then not slouching. So I would sit up straight, and it's, saving those images locally. It's not transferring them or anything. And then when I'm done, I click download, and this uses JS zip to load my images. So here are the pictures of me slouching and sitting up straight. So so that's how I downloaded these images. So just zipped all of them and download them. And this camera stuff, that again, that's not code that I wrote. I took that from webcam.js. Let me see if I can find an example of that. So, okay, so this is webcam.js. And here's a basic demo of it. So github.com/jhuckabee/webcam.js. Let me turn off my camera. Okay, and does what I showed you before, just take snapshots, and that's all it does, just take snapshots. So my code was, I really just took this, and after it saved a snapshot, I just saved it in that zip file. That's all my training thing did. It just took this, I modified it to save the files with the label. So it was fairly simple once somebody put this this library together. It was really easy to build something off of that. So I built this page like I showed you to record you slouching and sitting up straight. I sent this link out to contacts, to friends and people on Facebook, and try to get people to fill out this thing, send me their training images, and I got about 30 people to do it. I also put up a posting on Amazon Mechanical Turk. So if you're not familiar, basically you can pay some, usually not a large amount of money, but to do some sort of task. In this case, I just put a link to that page that I just showed you, and people would record their training images and then email them to me. So I had a few people do that. And again, it only takes 1 or 2 minutes. It's very, very quick. So a few people were able to give me their images through Amazon Mechanical Turk. And all in all, I got about 30 training images that I could use. I think in the future, I did learn a few lessons about trying to get training images, make this as short as possible. I think I probably should have used a video of me talking instead of having the instructions written out. I probably should have just put a YouTube video or something where I describe what I want people to do. Maybe I should have had a raffle or something as well. So there were probably some things I could have done to make more people willing to give me their training images. But I did get 30, so that was, I think, enough to work. 30 people, each person gave me maybe 40 images or something. So that was enough for me to work on. So once I had the training images, I basically built the model. So I have, this is my data pipeline. I have my training images and my validation images. I put them through this model. I got my final model. I did model.save. Then I converted it using that converter that I showed you before. So this converter, which is really just, one line of code, and I got these two files. I took these two files and I put them on online. So here they are, model.json, and and these bin files were the output of the model. There were more, I think, because I was using a pre-trained model, MobileNet, so I think that it was a bit of a bigger model, so there were more bin files, not just one, there were 4 of them. Just one thing to note, I had to make some changes to this JSON file. I think it might be helpful just tell you what they were in case you have the same issue. So number one is there's something here that says path. So here's his paths, and if it's in a subdirectory, like in my case, it's GitHub, GitHub, whatever, slash, the subdirectory. So you have to manually put into this JSON file, or else it won't be able to find them. It'll look in the root directory. So that was one thing that took me a while to figure out. The other thing was when I used MobileNet, there was one thing here called there's one parameter here. It said like here it is. Instead, right now it says model. Before it said functional, and I had to change it to model, and then it worked. Beforehand, it caused some issues, and the model wouldn't work. So that's the second thing I did. So the first thing I had to change the paths, and the other one was I had to change the word functional to model before it was able to work in the browser. So that's a JSON file, and basically, if you look at this tutorial that I showed you with a cat prediction here, so you'll see that there are 2 files there. There's, I think, called index.js, which I called it this, and the index.html, as well as the bin files, the JSON file, and then like a random image kind of start off the model. So the index file the HTML file is pretty basic. There's nothing too exciting there. I modified it to load some style sheets, and like the webcam.js. Here it is. So I had to modify it a bit, but it's a really basic file. Most of the work is done in this. It was called index.js, and like I showed you before, basically loads the model, and then it makes predictions, and it adds a few other things where it kind of plops the predictions in a nice image and shows the categories and stuff, the probabilities. So I kept all that, but I added a little tiny bit more. And then I added in some stuff from the webcam.js to basically record the snapshots and save them and stuff locally, of course. So again, so this was the model I built. Again, I uploaded it here. So I have that JSON file and the bin files, which are the model itself, the HTML file, this prediction, the index.js that I renamed, and some stuff to deal with the webcam and to handle the clicking and stuff. So that was it. It was a pretty basic model, and it's fairly accurate, I think, on me, because I'm in the I'm in the training set. For people not in the training set, it's less accurate. So it did overfit, I think, a little bit. And I think the way that I would fix this in the future, rather than being based on an image of me, I think what I would have based on is like what's called a pose estimation model. So people have already built models where you can upload a picture or a video stream, and it kind of indicates the coordinates of your eyes, your nose, your mouth, your shoulders. So PoseNet is one example of that. So this is PoseNet. So you could see that it's drawing circles over some objects of interest on the person's face, their shoulders, their other joints. And behind the scenes, what it's doing, it's calling an API, and it returns these coordinates of X and Y coordinate of the nose, of the left eye, of the right eye, and so on. And I think what I would have done to improve the accuracy and kind of reduce the overfitting was put the model through this. Instead of saving training images like I did here, instead of saving images, what I would have done is put it through the PoseNet model and save the coordinates of these different body parts that it's picking up on, and then train the model on the coordinates. And that's much fewer dimensions. Instead of looking at pixels, it's looking at only a few coordinates. There may be 40 features here. So I think that would have helped with overfitting. And then when we put the model online, basically I would have called the same API, would have gotten these coordinates, and then fed these coordinates into the model instead of the image into the model. There are other pose estimation models out there. So here are a few other ones. There's this one, TF pose estimation, Hyperpose, OpenPose, EvoPose, and this one, TF simple human pose. So there are quite a few of these pose estimation models. So I think I would have had my pick. So to improve the accuracy and reduce the overfitting, I think that's probably what I would have done, but I didn't quite have time. So hopefully you found that interesting. If you have any questions, feel free to comment, let me know, email me, and the code is on GitHub if you're interested in seeing that. So I hope this was valuable to you, and thanks for listening.